Hey guys, we're going to work on the test review for the second 6 weeks test that's coming up next week. It's actually been pushed off till Wednesday, just FYI. You're going to be getting this review on Monday. We're going to talk about it more on Tuesday. We're probably going to play some type of game about it on Tuesday, and then you'll take the test on Wednesday, alright? So the very beginning of this paper, you see it's just the 6 graphs. We did this before on the other review. Let me tell you something. You need to be able to identify these 6 graphs. I know it has not come up on any test prior other than maybe a slight identification. You need to know this is what sine looks like. This is what cosine looks like. This is what tangent looks like. Alright, I don't even think, we didn't even put it on there, so you might need to write out next to it. Tangent x. Okay? You need to know, oh, let me get rid of that. You need to know that this is what cosecant looks like. You need to know this is what secant looks like. This is what cotangent looks like. It basically comes up on the test that you have to be able to identify. Okay? Genuinely. Alright, number 1. Which trig functions have a domain of negative infinity and positive infinity? Basically means which trig functions don't have a vertical asymptote. Well, that's only sine and cosine. Easy breezy. Sine, cosine. Which trig functions have a period of 2 pi? This one we should have memorized. Sine, cosine, and there's 2 more. Secant and cosecant. Very good. Which trig functions have a period of pi? That is tangent and cotangent. Okay, number 4. Which of the following trig functions are even? I am sure you have this memorized by now. But hint, 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 hint. It does not look like this on the test. It doesn't just give you these 6 and ask. You need to be able to look at the graphs and be able to see which ones have rotational symmetry and which ones don't. Because remember, to be even, you do not have rotational symmetry. What does rotational symmetry mean again? That's fine. Rotational symmetry basically means you could take a point and then you could go across the origin and get another point right there. So what do I mean by that? Let's start with cosine right here. Alright, let's start right here with this cosine right here, this point. Go down to the origin and then walk that same amount back the same direction. Did you get a point right here? No? So this would be even because it does not have rotational symmetry. What about sine? Look at sine. Let's take this point right here. Walk it back. Well, okay, we can't see the other side of the origin, so we're just going to kind of assume that this is the origin. Walk it back. Do you see another point right here? Yes? Okay. That has rotational symmetry. So this would be odd. Okay? What about right here? Take this point. Walk it to the origin. That would look like this. And then walk it back up. Does it have a point? Yes. So tangent is also odd. Alright, cosecant. I'm going to choose this point. Walk it over, walk it back up, same direction, same space. Does it have another point? Yep. So this is also odd. What about secant? Take a point, walk it, well, I'll just start right here. Take this point, walk it down to the origin, walk it back down. Is there a point right here? Nope. So this is even. Okay. Take a point, walk it over, walk it back. Does it have a point? Yep. So this is odd. You need to be able to identify based on the graphs, hint, 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 which ones are even and which ones are odd. Okay? Alright, so I can tell you that. We can circle them. These are even, these are odd. But that's not going to do you much good if you can't identify them based on the graphs. If you memorize the graphs and memorize these answers, okay, that works too. In which quadrant of the unit circle is tangent negative? Pull out your trig chart. Follow your trig chart down. What are the quadrants where tangent is negative? Tangent is negative in quadrants 2 and 4. And which quadrants is sine positive? Pull out your trig chart. Look at where sine is positive. That would be 1 and 2. Okay? Moving on. Question number 8. What is the domain of sine inverse? Well, here's sine inverse. We gave it to you on this paper. Negative 1 to 1. That's your domain. That's bracket negative 1, comma 1, bracket. What is the domain of cosine? Same domain. Exact same domain. Negative 1 to 1. Okay, here are the real hard problems. Simplify. Alright, so 1 minus sine squared. That is a trig identity. It comes from the trig identity of sine squared plus cosine squared. It comes from the Pythagorean trig identity equals 1. All we did was we moved sine squared over. So now we have 1 minus sine squared. So I can replace this with cosine squared. And then if you have cosine squared over cosine, that reduces down to just being cosine. Alright, 1 minus sine x times 1 plus sine x. Distribute, distribute, so you get 1 plus sine squared x. Distribute, distribute, minus, I'm sorry, why did I write square there? Someone should have stopped me. Alright, blame Matthew, he's taking a test over here. Blame him, he should have caught my error there. So then, negative sine x times 1, so minus sine x. Actually, Matthew stayed in here for like an hour when I wasn't even in here, so props to him. Negative sine x times sine x is negative sine squared x. These will cancel, so you get 1 minus sine squared x. Alright, and that is also a trig identity that I just used, which is cosine squared x. And that's all you can do. That would be your answer. Alright, number 22. Remember, this multiplies like a block. So you multiply it there first, so now we have cosine x sine x times cosecant x. And then this multiplies like a block to this one, so we say plus cosine x times sine x times secant x. Well, if you remember that sine and cosecant are reciprocals, they cancel each other out, so we just get cosine here. And if you remember that cosine and secant are reciprocals, they cancel each other out, so we just get sine here, so plus sine x. And there's my answer, cosine x plus sine x. Okay? Number 23, you can change cotangent to being cosine over sine, which then allows me to cancel out the sines. So I get cosine plus cosine, which is 2 cosine x. Okay, problem 24. Match the correct graphs. Okay. This problem, I suggest using a calculator for. Because look at A, B, C, D, or F, G, H, J, whatever. Look at their windows. Every window is the same. So turn your calculator on. If I can get mine on. This is always the weirdest part of this video. This is how hard it is to get my calculator turned on. I don't even know why it's so hard. Alright, anyway. So now you hit second quit, go to window. X min. What's your minimum x value? Negative 6 pi. So negative 6 second pi. Press enter. What's your x max? 6 pi. So 6 second pi. X scale. Alright, a good x scale in general is just pi over 2. Alright. You could use a different one for this problem, but let's not change things up. We've gotten used to using pi over 2, let's still use it. Y minimum, negative 5. Y maximum, 5. So then I quit. Now I just type in my function. Let's clear out all the other junk that I don't need. Are you done, Matthew?
Yes, sir.
You can come over and drop your paper off. So, 2 cosine. Now I have to put in extra parentheses 1/3 x. Close that parentheses. In your case, instead of doing the parenthesis 1/3, I would do alpha y equals enter, and then minus 2. And then I hit graph, and I wait to see which one this looks most like. And which one does this seem to choose? J. Okay, now let me give you another little hint here. On the test, you're going to get a very similar one. It is not the same problem. Don't just look at it and think it's the same problem. It is not the same problem. Okay? You can follow the same steps I just did. Make sure you realize it's not the same problem. Alright? Alright, so, okay, number 24 and 25 is not something we've ever done in class. And the reason we just only take 5 minutes to cover is because really how simple it is. It says, use a calculator and the inverse trig function to solve cosine A equals negative 0.12 in radians. Okay, so first off, just read each part of that question. Use a calculator. Alright, so we pull up our calculator. And the inverse trig function, okay, I'm going to show you how to do that, to solve this, so that means we want to find what A is in radians. Okay, so that means I need to have my calculator in radian mode, so I click mode, I check to make sure it's in radian mode, mine is. Then, how do I get a negative trig function? Well guys, look right above each trig function. You see how they're all negative versions of it? They're all the inverses of it? Okay, so to do inverse cosine, you just hit secant cosine. And then you just type in this number over here, negative 0.12, and then you press enter, and bam, that's literally the answer they're looking for, 1.69. So A is approximately 1.69. Okay, try to do 25 on your own. Pause this video and try to do 25 on your own. Hopefully you're just unpausing the video and you're like, no, that was so easy. Alright, you hit second sine, then you just typed in 0.10 0.45. Closed it, pressed enter, and you got 0.10. 0.10. So you got A is approximately 0.1. All right, easy breezy stuff. Okay, seriously, it's that simple. That's why we just don't ever take time to talk about it in class. We just talk about it briefly in the review. 26. Determine the period and amplitude. Okay, back to some of the older problems. You need me? 1 second. Okay, define the amplitude. Remember, that's just the positive version of the number multiplying to the function. So in this case, it's just 3. Remember, amplitude can never be negative. To find the period, we say 2 pi divided by the number multiplying to your variables. In this case, it's 1/3. When you are dividing by a fraction, you keep the numerator, you change the multiplication, and you flip the denominator. And 3 over 1 is really just 3. 2 pi times 3 is 6 pi. So our period is 6 pi. Pause this video, try to do 27. Hopefully you're unpausing the video and you're like, Mr. Allen, that was easy breezy. The amplitude is 3 again, because remember, amplitude can never be negative. And then the period is just pi. Well, how did we get that? How do we know it's just pi? Well, you find the period by saying 2 pi over b. b is the number multiplying to your variable. In this case, which is 2. 2 pi over 2, the 2's cancel, and you get just pi. Alright, problem 28. Determine the phase shift and vertical shift. Well, we have a minus pi over 2, so that means right pi over 2. So our phase shift is right pi over 2, and our plus 4 on the outside simply means up 4. Okay? 29, find the amplitude, the period, the phase shift of the equation. Okay, so the amplitude is just 2. I know it says negative 2 right here. I know that's the number multiplying to the cosine. But amplitude is never negative, so it's just 2. The period is equal to 2 pi over the number multiplying to our input variable. Our input variable is x, so it's 2 pi over 2. So our period is just pi. So our period is just pi. Okay? And then our phase shift, it says minus pi, so that's right pi units. So that's right pi. Okay? Moving on to problem 30. A ladder that is 20 feet long leans against the side of a house. The angle of elevation of the ladder is 70 degrees. How up the wall of the house does the ladder reach? So we have a ladder. It's leaning against the wall of a house. It makes a 70-degree angle right here. It's a right triangle. I know that the ladder is 20 feet long. I want to figure out how high up the wall of the house does the ladder reach. So here's the wall of the house. That's x. So this looks like a Pythagorean, I'm sorry, not Pythagorean, SOHCAHTOA situation. Alright, so we have an angle, we want to find the opposite, and we know the hypotenuse, because that's across from the right angle. So, opposite, hypotenuse, sine. So I can say sine 70, are you ready for me, Matthew? Sine 70 is equal to opposite over hypotenuse. So then we have x over 20, sine 70 is equal to x over 20. So to solve for x, I just multiply both sides by 20. These cancel, so I'm going to get approximately equals x, and then I'm just going to type 20 sine 70 in my calculator. But that's going to be degrees. So what I need to do, I need to go change my mode to degree mode. So then I say 20 sine 70. I press enter, and I get 18.8. I remember that I had to change my calculator to degree mode to do that. You're going to see that on the test tomorrow. 18.8 feet. Approximately 18.8 feet. Okay. Moving on. Let's go to problem 32 here. Alright, this is just what we've been doing. 2 sine theta minus 1 equals 0. Move the 1 over. So now we get 2 sine theta equals 1. Okay. Come on over whenever you're ready. And then I divide both sides by 2. So then I get sine theta is equal to a half. Okay. And then I just grab my handy dandy trig chart and I go down my trig chart looking for a sine theta is a half at pi over 6 and at 5 pi over 6. So theta is equal to pi over 6 and at 5 pi over 6. Okay. That's supposed to be a 6 there. Alright, so pause the video, try to do the next one on your own. Okay, so cotangent theta is equal to negative square root of 3 over 3. This one's easy. Just grab your trig chart, look at cotangent. Where is equal to negative square root of 3 over 3? 2 pi over 3. and 5 pi over 3. So theta is equal to 2 pi over 3, and again at 5 pi over 3. Alright, let's go to the last ones and then we're done. This is kind of a lengthy review video, but it is for a unit test, so it goes a little long. Evaluate secant 11 pi over 6. This is another one of those questions that we did not cover specifically in class because of how simple it is. It simply wants to know what is secant at 11 pi over 6. Guys, all it means is to grab your trig chart, find where secant is, find where 11 pi over 6 is, and you see that it's 2 square roots of 3 over 3. So the answer is 2 square roots of 3 over 3. Alright, same idea. Sine pi over 2. Grab your trig chart, find sine, go down to where you see pi over 2, and you see that sine would equal 1. Tangent at pi. Same idea. You grab your trig chart, tangent, pi, and you see that's 0. Okay, guys, I hope I answered your questions. If not, please send me an email. Please send me a remind. Message me on Canvas. Reach out to me any way you know how. I will respond. Even though I'm going to be gone this weekend, I'm going to be gone on Monday, I will respond. Okay? All right, thanks, guys.